And the first, it starts off with OFDMA. OFDMA stands for Octagonal Frequency Division Multiple Access. And this is different from the previous standard, which runs off OFDM, Octagonal Frequency Division Multiplexing. Okay, and what is the difference? I would like to illustrate it with this example of a truck. So this is OFDM, right? And you have a truck. Now that truck represents really the channel width. And when I say the channel width, it means that when we configure the AP, typically there is a configuration called the channel width. It determines the width of the channel. It can be 20 megahertz, 40 megahertz, 80 megahertz, or 160. Now, in most cases, for 2.4 it is 20 megahertz. In 5 gig, it is default 80 megahertz. So it represents the size of a truck. The bigger the number is, the bigger the truck size. It can carry more data. Okay, and so if I have a truck of a certain size, let's say a 20 megahertz channel width will mean a truck of a certain size, and I want to transmit to my 3 devices, what will happen is that that truck is going to carry 1 packet for 1 device, and then separately another trip to carry a 2nd packet for the phone, and the 3rd trip to carry another packet for the iPad. That is how existing Wi-Fi works, OFDM, one at a time. And that's why I say it's kind of like, inefficient, okay? Right, and with OFDMA, what it does with OFDMA is that now that channel width is divided into sub-channels, okay? And these sub-channels are called resource units, and the smallest resource unit is RU26, and a single 20 megahertz channel can hold up to 9 resource units, okay? And what it allows the AP to do now is to assign every client with a resource unit, okay? And pack them into a single transmission. So this truck now makes 1 trip and can deliver all 3 packets simultaneously to 3 users, giving them their assigned RUs or assigned sub-channel. Okay, so this is the big difference with OFDMA. And this makes it so much more efficient because it can serve more clients and also have lower latency. Because now the other clients do not need to wait. Remember, in the first case, when the truck is serving 1 device, the other 2 devices have to wait for their turn. Okay, and so this is great for low data rates transmission, because in the low data rate, the truck moves slower. And so by being able to carry more packets, we are optimizing that trip, making it more efficient. Okay, and so OFDMA is important. It works for downlink. It also works for uplink. Okay, which means that multiple devices can simultaneously send to the AP without causing a collision. Okay, so this is interesting. All right,